Very good evening, Neha. So yeah, okay, let's start it or not. Let's see. Okay, chalo. So yeah, very good evening, Neha. So very good evening to all. So this is Mayur S. More, your chemistry tutor. So as we all know, we have started a chapter called Iupac nomenclature, right? Now this chapter comes into GOC only, okay? But I have kept it in a separate section where we're gonna see the nomenclature of it, okay? So we have already covered the 3 sessions of nomenclature. Now today we are into the fourth session of our Iupac nomenclature, okay? In the previous sessions, we had seen how the different common names and how the organic chemistry was evolved, how different organic names were given, what are derived names, what are word root and all that, okay? And today we're going to take that discussion forward to see the naming of alkane, alkenes, alkynes, then the cyclo compounds, okay? So on that note, let's begin. I welcome you all to NEET Chemistry, session number 4. Let's begin. As the rule suggests, if the same substituent, see, if the same substituent occurs more than once in the molecule, if the same substituent occurs more than once in the molecule, then the prefix such as di for 2, tri for 3 are used to, they are used, okay? For example, now let's look at this compound. This compound is started with name what? 1, 2, 3, 4, 5, 6, 7, right? That's the naming of it. Now you can see on the second position, you got the methyl here. On the third position, you got the methyl here, right? Then you take a turn to go 4, 5, 6, 7. On the third position, you have an ethyl group like this, okay? And on the fourth position, you have a propyl group like this. Now, how would you name this compound? This compound would be named as, it would be named as 2, comma 2 dimethyl. Now let's see. So these are methyl. This is what? This is ethyl, right? Ethyl, methyl, and this is what? Propyl, right? Now you only tell me alphabetically which should come first. Ethyl should come first, methyl should come first, or propyl should come first. Now we all know that alphabetically ethyl should come first, right? So therefore you need to write the location of ethyl first. What position it is present at? It is present at third position, right? So it would be named as 3 ethyl, comma 2, comma 3 dimethyl. 3 ethyl, 2, comma 3 dimethyl, 4 propyl. 4 propyl. And how many carbon atoms are there in the longest chain? 1, 2, 3, 4, 5, 6, 7. So 3 ethyl, 2, comma 3 dimethyl, 4 propyl heptane. That is how you should name this compound. Now, some of you might say, so in the dimethyl, there is a D, right? And we all know that D comes before E. So let me tell you, this di, this tri, these are what? Prefixes. And you should not consider, you should not consider prefixes. You should not consider prefixes in, don't consider prefixes in alphabetical order. So you should never consider any prefix or any suffix in alphabetical order at all. Okay. The real name, which is ethyl, methyl, for that you need to use the alphabetical order, not for these prefixes. Okay. Sure. Moving ahead with this. Now let's summarize some of the rules. See, the name of your compound is composed in such a manner that each substituent with its number and its name is written in alphabetically just before the parent name. Now we just saw, right? Then you also need to use the prefixes like di, tri, tetra, okay? again are not considered in deciding alphabetical order, which I just told you, right? You should not consider this prefixes di, tri, tetra or any suffixes for that matter in an alphabetical order. The parent name and the name of the substituent should be considered in alphabetical order only. Okay. So just like that, ethyl will be written before methyl and which will be written before propyl. Okay. You just saw that. It is just the explanation of that only. Okay. So that's it. Now again other things, what? Numbers are separated each other by commas, which I already told you. Numbers are separated from the words by what? Hyphens. And write the name of the compound as a single word with no space. That is no need to tell that, okay? That you can understand. So, what should be the name of this compound? Now, if you look at this compound, the longest chain is what? 1, 2, 3, 4, 5, 6. Longest chain is right there, right? On the second, you have methyl. On the third, you have what? Ethyl. On the fourth, you again got the methyl. So, how do you write the name of this compound? It would be ethyl. It would be 3-ethyl. Then what? Dash 2, 4 dash dimethyl hexane. Okay, it will be named as 3-ethyl 2, 4 dimethyl hexane, isn't it? So that's how you should write the name of this compound. Okay, if you have any doubt with this, you can ask me in the comment section. Okay, chalo, moving ahead with this. What are the Iupac name of the following compounds? Now again look at this compound. The naming, I deliberately put the naming there so that you could understand. See the naming 1, 2, 3, 4, 5. On the second you got 2, 1 methyl, 2 methyl there. On the third you got 1 more methyl. So how do you write the name of this compound? 2, 2, 3. Trimethyl. 2, 2, 3 trimethyl pentane, right? That's how you write the name of this compound. Okay, now that was quite easy, right? What should be the name of this compound? Look at it. 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is a complete straight chain, right? 9 means what? It's a nonane. So 9 means it's nonane. Now what should be the name of this compound? See, as I told you earlier, you should consider this compound. Now, this is substituent. That's fine. This compound is a substituent. But you need to name this compound also in a Iupac manner. Now, how to name this substituent in a Iupac manner? See, as far as this longest chain is concerned, you can start counting from anywhere. Even if you start, even if you would start counting from this side, you get 1, 2, 3, 4, 5. Here also you would have got this at the 5th position. Here also you would have got this at the 5th position. So that is the same thing, right? There is no change in that. Fine. Now, so the second thing, see, this substituent starts from this carbon. Which carbon? Let me take the another color. See, it starts with this carbon. This is the first carbon of it. Now in a substituent, you need to select the longest chain. The longest chain that you could select in a substituent is having how many carbon atoms? 3 only, right? 1, 2, and 3. 1, 2, 3. So first position of that substituent, you got a sub-substituent. That is this methyl. And the second position also you got the methyl. So how would you name this compound? So if you consider the longest chain, it is present at the 5th position of the longest chain. So you write the 5 into bracket. What do you write? You write the substituent of substituent. See, this circular red circular part is a substituent of a longer chain. And these 2 methyl groups are substituent of this substituent, right? So you need to write these sub-substituents first, right? So how to write them? It is at the first position and second position. So you write 1, 2 1 comma 2 dimethyl, 1 comma 2 dimethyl. And how many carbon atoms are there in the longest chain? 1 2 3. 1 comma 2 dimethyl propyl, 1 comma 2 dimethyl propyl, bracket complete, comma. How many atoms are there in the longest chain? 9, right? So 5 dash 1 comma 2 dimethyl propyl nonane. That is what the name of this compound is all about. That's how you name it. Okay. So moving ahead, if you have any doubt, you can ask me in the comment section. Okay. I will try to answer it. Sure. Moving ahead now. Now, the last part of the alkane series. Now we also have an alkene after that. Okay. We need to understand how to name them also. So where do you start counting from now? 1, 2, 3, 4, 5, 6, 7, 8. If you would have start counting from this side, 1, 2, 3, 4. At the fourth position, branching would have come. But here at the third position, it's a methyl. Fifth position, it's a ethyl. So naming of this compound is quite easier. What would you name it? 5 ethyl, 3 methyl octane. Isn't it? It's quite straightforward. There is no complexion in that. Okay. Now this compound. How would you name it? You might name it as 1, 2, 3, 4, 5, 6, 7. Okay, that is the way. Or you can also name it as 1, 2, 3, 4, 5, 6. Even if you go up, it will still be 7. Even if you go down from here, it still will be 7. Even if you go straight, it still will be 7. Okay. Now that is clear. This is a whatever way you go, it would be having 7 atoms only in a longest chain. Now you might say, shall we consider this red color numbering or this blue color numbering? See the red color numbering, what happened? At the second position, you got 2 substituents, methyl, methyl. Okay, and in this blue color numbering, you got only 1 substituent at the second position. So in both the numbering, you got substituent at the second number only. So you can consider both. But in the red color marking numbering, there are 2 substituents on the second position. Whereas in a blue color numbering, there is only 1 substituent on the second position. And you should consider that numbering where you would have more number of substituents on the lowest number. And that is why the red color numbering should be proper. Now what is it? On the second position, you got the 2 methyl. On the fourth position, you got the ethyl. And on the sixth position, you got the 1 more methyl. So how would you name this as? You would name this as 4 dash ethyl, right? Dash 2 comma 2 comma 6 trimethyl heptane. Trimethyl heptane. That is how you named this compounds. Okay. So moving ahead to the next compound. Look at this compound now. If I draw this compound structure in a larger so that it is visible to all of you. So now here where would you start counting from? Suppose if you start counting from here, 1, 2, 3, 4, 5, or you can start counting from here, 1, 2, 3, 4, 5, 6. In fact, that is how you need to count this. Why? Because in that way you are getting the longest chain, isn't it? The very first thing, the very primary rule of Iupac is what? The very primary rule is to get the longest chain. Then there will be branching rule. Then there will be more branches or less branches. Okay. So everything comes after that. So if you can see this black colored would have black colored numbering has the longest chain. So we need to consider that only. Because in the blue color, you are getting only 5 carbon atoms. So if you consider black colored marking, at the second position, you got the methyl. Sorry, third position, you got the methyl. So how would you name it? Straightforward, right? It's a 3 methyl 6 carbon atoms hexane, right? 3 methyl hexane. It's a straightforward. It's quite easy, right? So I hope you must have got this very well. Even if you have doubt in that, you can ask me in the comment section. Okay, sure. Moving ahead. Now, the Iupac nomenclature of alkenes. See, you need to understand the Iupac nomenclature of alkene also. Now here, if you ask me what is a functional group in alkene, see, alkene is also hydrocarbon. Alkene is not as such a functional group, but here, for you to understand the naming system, we need to consider this double bond as what? We need to consider this double bond as nothing but a functional group. Okay. So that means you should do the counting here where double bonded carbon get as low number as possible. So again the rule, select, what is the rule here? Select the longest chain containing carbon-carbon double bond. So you need to consider the double bond first. Here, it might happen that suppose there are two countings in a particular compound. In a one counting, you got a 6 carbon atom, but double bond is not coming in that. And in a second counting, you got only 5 carbon atoms, but double bond comes into that. So you need to consider that counting where double bond is coming into consideration, because that is the functional group here. Okay. So that is what, see, I have written also. This need not be the longest chain in the compound as a whole. It may not be. It could be. I'm not saying it is not. It could not be, or it may not be the longest chain. It could be the second longest chain in the whole compound, but it should have a double bond. Okay. The parent name will be alkene, corresponding to the number of carbon atom in the longest chain. That we had already seen, right? See, the name of alkene has been derived from the name of alkanes only. You just remove one E, right? How do you write it? This is alkane, right? Now what you do, you remove A, subtract A and add E. So what do we get? Alkene. So you might say, sir, I know this and all that, but yeah. See, if I give you hexane, hexane. So it's alkene. How would you write it? You remove the A, you add the E. It will become what? Hexene. Just like that. Okay. That is how the naming of alkenes are. Now we're going to obviously see the example. Okay. But before moving to that, I'm just telling you all the fundamentals. So yeah, carbon atoms in the longest chain numbered so that doubly bonded carbon atom gets the lowest number. As I told you, you should do the counting in such a way so that doubly bonded carbon gets the lowest number. Okay. The position of double bond is indicated by the smaller of the number assigned to two carbon atoms of the double bond. Okay. Let's not go much into text section. Let's see the direct example. Yeah. Now look at this compound. Now I have already told you here how we can count this. As I told you, you should give the double bond as low number as possible. So if you look at here, the double bond is rightly present at the very first carbon atom. So this is 1, 2, 3, 4, 5, 6, right? So now you might say, so which double bond shall we take? Because double bond is present between 1 and 2 carbon atom, right? So shall we take 1 or shall we take 2? Between 1 and 2, which is smaller number? 1. So therefore you should take the 1 only, right? And then this third is your what? Substituent. This is also your substituent. So how would you name this then? You would name this as 3-ethyl dash 3-methyl Now, there is no dash actually now. There is a comma. 3 ethyl dash 3 methyl. Then how many carbon atoms are there in the longest chain? 5, right? Pent. Now, pent, you can write a pentane directly, okay? But there is a one more naming system. Let me tell you that now. See here. CH3, CH3, CH, CH, double bond, CH, CH. See, this is the compound. So name of this compound is nothing but this. Straightforward, pentane. Okay. But see, there is a one more breaking of this. So how would you name this compound now? The one which I write here, you would write it as like 1, 2, 3, 4, 5. Okay. That is the one way of counting it. That what is the second way? Second way would be right. 1, 2, 3, 4, 5. Now, when you go by this black colored way, the double bond is coming at the third position. But when you go by this blue colored numbering, double bond is coming at the second number. So, therefore, this numbering is wrong and this blue color numbering is right. Now, why did I bring this? Let me tell you. So, at the fourth position, you got a substituent. That is fine. That you also know. 4 methyl, comma. Now, the longest chain has 5 carbon atom, right? So you can't write pentene directly. You also need to tell the position where double bond is present. In this example, double bond was present at the very first carbon. So you just wrote pentene. But here you can't write pentene. You need to write pent number. What is the number? 2 and 3, right? It could be 2, it could be 3. But between 2 and 3, which is smaller number? 2 is a smaller number. So you should write 2 now here. 4 methyl pent dash 2 in. That is how you name the alkene. So basically, alkene should be named as alk. It should be named as alk dash number of carbon where double bond is present dash in. That is how you name the alkenes. Alk dash number of carbon where double bond is present and in. Now, if that number is 1, then you can write the pentene directly. But if it is more than 1, if it is 2, 3 like that, then you need to mention that number. That is what I told you here. So it's a 4 methyl pent dash 2 in. That's how you name it. Okay. So moving ahead. I hope you must have understood it pretty well. Okay. So yeah. Now, how would you name this compound now? See, if I start counting it from this position, 1, 2, 3, 4, 5, 6, 7, right? Double bond is present at the third position. Now, you can also count it from the alternate way. For example, like this: 1, 2, 3, 4, 5, 6. But if you go by this, you are getting only 6 carbon atom. Okay, you are getting alkene at the third position, but then you are getting alkene at the third position in this red color counting also. Okay, but in the red color counting, you also have a longest chain, which you do not have in this black colored counting, and that is why this red color counting is right and this black color counting is wrong. So these are the small things. Yes, Rajneesh, very good evening. Are you angry on me? Why did you put that smiley there? So anyways, so if you need to do counting here by red color way only, right? So if you go by that, 1, 2, 3, 4, 5, 5 at fifth position, you got a methyl, right? So what do you write? 5 methyl, 5 methyl, comma, 7 carbon atoms, no? So it will be hept, right? Alk, no? So hept, what is the numbering of double bond? Third, right? Hept dash 3 in, hept 3 in. That's how the name of this compound is. Okay. Now the next compound. In the next compound, 1, 2, double bond is present at second position. 1, 2, 3, 4, 5, 6, 7, 8. So if you go by this, you are getting what? 8 carbon atom. If you go by straight, then also you are getting 5, 6, 7, 8 carbon atoms. Okay. So that is one of the way. Now, do you okay, artifacts. Hi, very good evening. Your name is what? Rohit. Oh, Rohit. Okay, so good evening to you. So yeah, so as I was saying here, red color counting 1, 2, 3, 4, 5, 6, 7, 8, or even if you go straight, it will be still 1, 2, 3, 4, 5, 6, 7, 8. Okay, but you also need to see at which position you get the maximum number of branches now. Now see, there are two alternate ways here. If you go by straight, then also you are getting 8 carbon atom and double bond at the second. If you come to the fourth position, then you come down, then also you are getting 8 carbon atoms in the longest chain and double bond at the second position. So that is common in these two countings. Okay, but if you go straight, you get so many branches. You get this methyl, okay? You get this methyl, you get this ethyl, you get this methyl, and this whole part is also substituent. So you got basically get the 4 substituents, okay? But if you take turn from fourth position, if you come down 1, 2, 3, 4, 5, 6, 7, 8, then you get the substituent only 3. How many? This methyl, and whatever is left there. So that is why you should consider here the straight chain where you are getting more number of branches. Okay. And then now what do you name this? See, if you look at, now let me rub this because I need a little bit space here. So this is our counting. Okay. I already told you what the counting is. If you want to see it again, you can pause it. So 1, 2, 3, 4, 5, 6, 7, 8. That is how we're gonna come. So this is our substituent. This is substituent. This is substituent, and this is also your substituent. Okay, now, so this first one is methyl. Okay, 1, 2, 3, 4, and then 5, 6. At 6, you again got the methyl. Okay, what are you telling? You can tell, sir, I am new. Okay, artifacts, no problem with that, beta. I'm telling. Okay, so 6. At the fifth, you got the ethyl. At the second, you got the methyl. So at second and sixth, you got the methyl. At fifth, you got the ethyl there. Okay, now when you come down, so this is a very large substituent. You can see here. How to name it? So on naming, as I told you earlier, this substituent itself should be named according to Iupac rules. Now you need to consider here the counting of the substituent itself, and its counting should always start. The counting of carbon atoms in the substituent should always start from the carbon where it is attached to the longest chain. Okay, so it's not that you can start from here because branching is there. No, you should start counting from this number only. Why? Because that's the part which is attached to the longest chain, isn't it? So 1, 2, 3, 4. So that is the longest chain. At the third position, you got what? Methyl substituent. Okay. So what is the name of this compound now? So if you write the name of this compound, it is what? It's a 3-methyl butyl. Okay. 3-methyl butyl. So B is coming first. So you should write that name first. It is present at what? Fourth position, right? So 4 dash into bracket. What? 3-methyl dash 3-methyl comma butyl. That is at the fourth position. Then at second and sixth, you got what? Methyl. At fifth, you got ethyl, right? So B should come before the E. That is why I have written this first. Now dash 5 ethyl, right? Then dash 2 comma 6 dimethyl, 4 dash into bracket 3 methyl butyl dash 5 ethyl 2 comma 6 dimethyl. How many carbon atoms overall? 7 and 8. Oct. After this there is a oct. Double bond is at the second position. Oct 2 in. That is how the naming of this compound is all about. Okay. So yeah, so that is what the Iupac nomenclature of this compound. Okay, so moving ahead. Now here you need to write the structures. You need to write the structures of this compound from their names. So if you look at their names, whenever you are asked to write the names, no, let's look at this first. Heptene. Okay, so heptene means what? One. These are 3 carbon. 5 7, right? At the third position, you got a double bond. So you have liberty to choose where you can put a double bond. You can start counting from right hand side, or you can also start counting from the left hand side. Doesn't matter. Let's suppose if I start counting from the right hand side, 1 2 3, right? So my double bond should come here between 3 and 4. When it's a 3, that means double bond should come between 3 and 4, right? 1 2 3 4. And at the second position you got what? Methyl. So here you have a methyl. So that is how this structure should look like. And lastly, diene. Okay, we will talk about this structure later on. I can tell you here, see, if there are 2 double bonds, then you need to write diene. Di means 2. In stands for double bond. So there are 2 double bond. Okay. So this is hepta 1 comma 5 diene. So hepta means again 3, 5 and 7 carbon atoms are there. So at the first position you got a double bond, right? 1 2 3 4 5. Here also you got a double bond. Just a sec. So yeah, here also you have a double bond 1 2 3 4 5. Okay, hepta 1 comma 5 diene, 2 comma 6 dimethyl. So here you got the methyl CH3, and 6 here also you got the methyl. So that is how this structure should look like. So since you have a 2 double bond, you write there as diene. If you have a 3 double bonds, you would write what? Triene. That means 3 double bonds. If you have a 4 double bonds, you write what? Tetraene, and so on. Okay, that is how you write the naming of all these compounds. Okay, so moving ahead. Now the Iupac nomenclature of alkyne. Now I won't take you into much complication here. Look, Iupac nomenclature of alkyne, it is just same. It is just same as what you followed for alkene. There is no difference. It is exactly like that only. Okay. So again, let me tell you 1, 2, 3, 4. Right? How do you name this? Now the triple bond is present at the 4th position. And how many carbon atoms are there in the longest chain? There are 4, right? So what do you write then? For 4 carbon atom, you would write but, right? But 2 YNE, butane. Or you can also write as 2-butane. You can also write as 2-butane, just like that. It is very simple. So instead of in alkene, you use ENE, right? And in alkyne, you use what? YNE. That's the only thing. So you remove E here and you add the Y here. That is the only thing. There is no other thing here. Okay. Now, moving ahead. next compound. 1, 2, 3, 4, and 5. At the fourth, you got two methyl groups, right? Then how do you name this? 4, 4 dimethyl, 4, 4 dimethyl. Then what do you write? Comma, pent. You can write the pentyne directly because it is at the first position. So 4, 4 dimethyl pentyne. That is how you name this compound. Okay. It is not that complicated as such. So moving ahead with this now. So Iupac, you can again write the name of this compound. It's not that complicated. 1, 2, 3, 4, 5. Again, this is your substituent, right? Triple bond is present at the second carbon. So how do you write again this? 4 methyl, comma, pent, or you can say 2 pentyne. 2 pentyne. See, it's quite easy. Not at all complicated. Again here, 1, 2, 3, 4, 5, 6, 7, or 5, 6, 7. So you go anywhere, doesn't matter. Both sides you will have 3 carbon atoms. Okay, that means it's a propyl. So what do you write this as? 4 propyl. You know? So suppose if I go up, so I would have a 3 carbon atoms here. 1, 2, 3. So 3 carbon atoms means what? It should be named as propyl. So 4 propyl dash. At second position you got a triple bond, right? 4 propyl 2 heptine. That is how you name it. It is that straightforward and that easy. Okay. So moving ahead. I hope you must have understood it pretty well. Even if you have any doubt, you can ask me in the comment section. Okay. So moving ahead. Yeah. The next part is Iupac nomenclature of hydrocarbons containing both double and triple bond. So there are compounds which has only, so which has double bond as well as triple bond, but only once. Okay, that means there would be only one double bond and one triple bond, like that. So such a hydrocarbon, how would you name them as? Alkyne, not alkyne. You name them as alkyne. So basically you take the E first, then you add the Y later on. Basically what? Numbering. Numbering is done in a manner that double and triple bond gets the lowest possible number. That you already know. Okay. We had already seen that in a separated part of naming of alkenes and alkyne. But what is the part that is interesting here? That in case of choice, the double bond is given a preference. Double bond is given a preference over the triple bond. So double bond gets the preference. Okay, double bond should be coming first. So how would you name this compound? 1, 2, 3, 4, and 5. You can't count. You can count this compound like this. 1, 2, 3, 4, 5. So here you should get the double bond priority than the triple bond. So you should write this compound's name as, this is pent, 5 carbon atoms. So pent. At the second position you got a double bond, right? So pent 2 in dash 4 wine. So what does this indicate? Pent 2 in 4 wine. That means at the second position you got the double bond, and at the fourth position you got the triple bond. That is how you should name it. So it's basically pent in 9. Okay, but you also need to mention the position of that in and wine. That is why I put the 2 and 4 before their names. Okay, so moving ahead. Yeah. How do you name this compound now? Pretty simple. Start with the double bond. You got a double bond here. 1, 2, 3, 4, 5, 6, 7. You might say, sir, why didn't you come down? I didn't come down because I also need to I also need to consider this triple bond. Triple bond should also be taken into consideration along with the double bond. You can't ignore it. So that's a straight chain. And this is your substituent now. And how do we name the substituent? 1, 2, 3, right? At the second position, you got the substituent of substituent. So you would write this as 3 dash into bracket 2 methyl 2 methyl comma propyl bracket complete, right? Then hept you can directly write in there, no problem, because it is at the first position, right? But you can still write hept 1 in. You can't put e there because there is going to be y there after all. So 1 in 4 y n e. So 3 dash into bracket 2 methyl propyl hep dash 1 in 4 y n e. That's how you name this particular compound. Okay. Moving ahead. Now you can directly name this compound, no problem. 1, 2, 3, 4, 5, 6, 7, 8. Okay. So this is kind of a homework for you. You name it and tell me in the comment section next lecture of the Iupac. Okay. Till then, we'll move ahead with this chapter now. Now, the most important part of today's lecture is that Iupac nomenclature of alicyclic compounds, basically cyclic compounds. Okay. Now, as far as cyclic compounds are concerned, you all know that names of alicyclic compounds are obtained by adding the prefix what? Cyclo. You put the cyclo before their names. For example, if this is the compound, what do you write this as? Cyclo. How many carbon atoms are there? There are 1, 2, 3, 4, 5 carbon atoms are there, right? So basically it's a pentane, but still, since it's a ring, you need to write the cyclo and the prefix before its name. So it's a cyclopentane, just like that. And otherwise, other things I have already told you. See, this is cyclopropane, this is cyclobutane, right? This is what? Cyclohexane. Then you have, this is what? 1, 2, 3, 4, 5, 6, 7. This is cycloheptane. Then you have this. What is this? Cyclooctane. So just like that. That is how you put a cyclo before their names. But sometimes you might have a double bond also. You might have a double bond also there, or sometimes you might have a substituents. But before going to substituent, let me tell you, suppose this is cyclopentane, right? And suppose if I have this compound like this, wherein I have a double bond here. Now how would you name it? Now, since you have a double bond there, you need to start counting from your double bond only. Now, this double bond, since I'm starting the counting from double bond position only, it's a first position only. 1, 2, 3, 4, 5. So what do you call this as? Cyclopentane, right? You just remove this A and you add the E there. So what do you call this as? Cyclopentene. Basically, it's a cyclopentene, right? So just like that. That's how you name this compound. Cyclopentane, cyclopentene. Okay. Now, what is the other part now? See, the numbering of the carbon atoms in the ring is done in such a way that substituent which comes first in the alphabetical order is given the lowest possible number. Now, understand one more thing here. Earlier, earlier, what did we see? That your ethyl, see, your ethyl was coming alphabetically first, or I would say ethyl was coming alphabetically prior to your methyl, right? So ethyl, methyl, propyl, and what did we do there? Whatever number your ethyl comes in, we just takes that number and we used to put it. We doesn't care whether that number is smaller, larger, doesn't matter. It should be alphabetical order there. But when you come here, these numbers are slightly folded. What are the thing is that the naming, that means whenever you have an ethyl and methyl, then you need to make sure, you need to make a try so that ethyl would have a lower number than the methyl, because ethyl anyways is going to come first than the methyl. So ethyl should also get the lower number. That is what they are saying, okay, in this particular case. So that is what they are saying, that the substituent which comes first in alphabetical order is given the lowest possible number, provided it does not violate the lowest set of locants rule. Lowest set of locants rule I have already told you in the last lecture. What was lowest set of locants rule? Whatever substituents you have there, you just add their numbers, okay? And if that number is smallest, suppose there are two or three, what I would say, there are two or three possibilities of counting, and all the counting is having everything same, but only their number is different. What number? The number where substituents are present. Then you need to take all those numbers, then you sum it. After summing, the possibility which has the smallest sum should be considered as its Iupac name. And that particular rule is called as lowest set of locants rule. Or earlier it was also used to call as lowest sum rule. It is also called as lowest sum. Okay, so that is how all of their nomenclature is all about. Okay, so let's see now. See, as I told you, what is the name of this compound? See, you can start counting here. You would have start counting from the methyl also. But as per the rule, what is rule? Ethyl should come first, because alphabetically anyways ethyl is coming first. So we try to give it as low number as possible. That is what they did here. So 1, 2, 3, 4, 5, 6. So name of this compound is 1-ethyl 3-methyl cyclohexane. Just like that. Okay. Similarly, this second compound, how would you name it again? Now 1, 2, 3, 4, 5, 6. Here it is 2-ethyl 1,4 dimethyl cyclohexane. Now let's consider the another possibility. Which possibility? Wherein we start counting from the ethyl only. We can do that also, right? But let's see what is the set, what is the, where is it lowest sum rule being followed there or not? Firstly, look here. You add all this number. Which number? 2, 1, 4. 4 plus 1, 5 plus 2. It is totally 7. So totally there are 7 numbers. Okay. Now let's see that other possibility where you start counting from here only. Where 1, 2, 3, 4, 5, 6. Okay. So when you go by this method, what do we get? 1 plus 2, 3, right? 1 plus 2, 3. Because how would you name it? You would name it as 1-ethyl 2,5 dimethyl cyclohexane. Now what is the sum of this locant here? See, 1 plus 2 plus 5. 5 plus 2, 7 plus 2 is equal to 8. And 8 is larger than 7, right? Because they have said there, I told you in the last slide only, you can do this. You can start counting. You can take ethyl earlier than the methyl. but only it is only allowed when the sum of that is lowest. But sum here, when we do that, the sum here is 8. Here it's a 7. Okay. Now let's see the third possibility. What is the third possibility now? Third possibility is you go by this way. 1, 2, 3, 4, 5, 6. Now this is further, this will have the number further larger. How? See, 1 ethyl, 3 comma 6 dimethyl cyclohexane. So 6 plus 3, 9, 9 plus 1, 10. It is further larger. That is why it is not allowed. And that is why you need to do at least ethyl a as low number as possible. And that is why this first name is the correct and these other two are not. Okay, sure. Let's look at the next possibility again. See, these are the things which might confuse you in the time. These are the things which might confuse you in the time of exam. Because in exam, there's a so much short time and you are pretty much busy in solving this question. So this might confuse you. So if you're already clear and well versed with these concepts beforehand, it will not confuse you at the time of the exam. Okay. So yeah, now we can spend as much time as possible here and we will spend that much time here, right? So yeah, look at here now. If I start counting from here, 1, 2, 3. What would be its name then? 1 ethyl dash 3 comma 3 dimethyl cyclohexane. Other part you already know. But here 3 plus 3, 6 plus 1, it would be 7, right? But here 3 plus 1 plus 1 is 5 only. That is why this is right and this is wrong. Similarly, here, then iodine, bromine, chlorine. You know which comes first, right? Bromine should come first, but you can't take, I mean, you start counting from any side. Bromine would always come second, right? So 1, 2, 3. So that is why they went by this 2 bromo, 1 chloro, 3 iodo, cyclohexane, because that is the alphabetical order. Bromine comes first, B, then chlorine, C, then iodo, I. Okay, so that is how the naming of this ring compounds is concerned. See, ring compound naming is so much confusing. I'm not saying it's a very straightforward. The straightforward nomenclature is for the alkane, alkene, and alkynes. When it comes to ring, it is always gonna confuse you, and that is where I'm coming into play. Okay, chalo. Moving ahead. Now, see, there are different kind of rings. We had seen that, and in those rings you would have a different kind of substituent also, and that will confuse you, so many times. Okay, so let's see some of those types. The very first type, the very first possibility, where when the ring contains more or equal number of carbon atoms, when the ring contains which equal number of carbon atom, what I'm talking about, the alkyl group or a substituent which is attached to your ring. So when the ring contains more or equal number of carbon atoms than the alkyl group attached to it, then it is named as a derivative of a cycloalkane and the alkyl group is treated as substituent. Okay, so let's look at here. In your ring, how many carbon atoms are there? 1, 2, and 3, right? You got 3 carbon atoms, and this is what? These are the 3 carbon atoms. So number of carbon atoms in the ring and number of carbon atoms in the chain are same. So in this way, that number of carbon atoms in the chain or that chain part, you should consider that chain part as a substituent now. And your parent name would be from the ring only. And that is why it will be named as propyl cyclopropane. Got it? Similarly here, this is the parent chain, cyclohexane. It is attached with the 3 substituents. And every substituent is having 6 carbon atoms there. See, 6, 6, 6. Then what do you name this as? 1 comma 2 comma 3 trihexyl, 1 comma 3 comma 5 trihexyl cyclohexane. Okay, so that is the thing where the substituent which is attached to ring is alkyl. What if the substituent which is attached to the ring is having same number of carbon atom, but that substituent is also ring? So here you can consider either this as a ring or either this as a ring. You can consider whatever. Suppose this is the ring and this square part is my substituent. Now square part is what? Cyclohexane. When you make it as a substituent, it will be named as cyclohexyl. And that is why its name would be what? Cyclohexyl. Okay. So that is how you named this compounds. Okay. So moving ahead, the second possibility. The alkane chain contains the greater number of carbon atoms than present in the ring. Then the compound is considered as the derivative of alkane. A ring is designated as substituent. So in the first possibility, what did we see? That the alkyl part which is attached to the ring was having same number of carbon atom as there was in the ring. But what if there are less number of carbon atoms in the ring and chain contains more number of carbon atoms? Then you should consider chain as your parent name and the ring as your substituent. For example, let me give you an example. 3-member ring, it is attached with CH2, 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 CH3. Now here in your chain, you got how many carbon atoms? 4 carbon atoms, right? And in your ring, how many carbon atoms are there? 3 carbon atoms. Then how would you write this? Now you would consider this ring as a substituent and you would start counting from this first carbon. Then how would you name this? 1, 2, 3, 4. You would name this as, this is cyclopropane, right? So 1 dash cyclo, propanes become propyl, right? 1 cyclopropyl comma butane. 1 cyclopropyl butane, just like that. Or you can have suppose 4-member ring like this, and suppose you have, right, so 1, 2, 3, 4, 5. 5 carbon atoms are there, but you should not start counting from that side. You should start counting from this side because you need to consider the substituent also, right? So this becomes 1 cyclobutyl, 1 cyclobutyl comma pentane, right? That is how they are named. That is what this rule says all about. Okay, sure. Moving ahead, the next part. If a ring has unsaturation means what? Double bond. Having a double bond is called as unsaturation. Okay. If a ring has unsaturation and side chain is saturated, then the ring is selected as a parent chain. For example, look at this. This ring has a double bond, okay, and you got what? Suppose 1, 2, 3, 4, 5, 6 carbon atom there. 1, 2, 3, 4, 5, 6. Yeah. So the number of carbon atoms in the ring are less than the number of carbon atoms in the chain, but still you need to consider this ring as a parent name because it has an unsaturation double bond, and double bond is considered as a functional group. Alkane is not considered as such as a functional group, right? So therefore, so what do you do now? You should start counting from here. 1, 2, 3, 4, 5. Just like that. Or, yeah, anyway, that is the way you can count it. So it will be what? 1, 2, 3, 4, 5, 6. So 2 cyclohexyl 2-cyclohexyl pent 1-ene. That is how you should name it. Okay. We're going to see examples of it also very soon. But firstly, let's understand it. Secondly, if the side chain, the chain which I'm talking about, this side chain, this is side chain. If the side chain has unsaturation and the ring is saturated, then side chain is selected as a parent chain. In other case, whatever part, be it alkyl side chain or be it ring, whatever part which has a double bond should be considered as a parent chain. And then the other part is considered as what? Substituent. Okay. So these are the second way. This is the first way. Second, what is the third possibility? If both have unsaturation, if both have unsaturation, the chain with maximum unsaturation, if both have unsaturation, then the chain with maximum unsaturation has selected as a match. Okay. Then अगर दोनों के पास डबल या ट्रिपल बॉन्ड है, दोनों के पास अनसैचुरेशन है, you need to consider that part, be the chain or be the ring, which has maximum unsaturation. Okay. And fourthly, these are the third way. Fourth way, if equal unsaturation is there, then longest chain is selected as a parent chain. That we had seen earlier also. So it is just like having no unsaturation. So when we do not have unsaturation, what was the case that time? If the ring is having larger carbon atom than the alkyl side chain, then we would consider ring as a parent and alkyl side chain as a substituent. If the alkyl side chain has more number of carbon atoms than the ring, then you would consider alkyl side chain as a parent and the ring as a substituent. Same thing will be applicable here also when both ring and alkyl is having same unsaturation. Okay. And lastly, is the last part. If unsaturation and number of carbon atoms, if unsaturation and number of carbon atoms both are equal, this is the fifth possibility, right? If unsaturation and both number of carbon atoms are same, then what to do? Then ring is selected as a parent. Okay. Now you cannot say here that, oh, this is unfair with the alkyl side chain. Why we are considering ring? See, these are the worldwide accepted rule. Now these rules has been imposed by Iupac, so we need to accept it. When both ring and alkyl side chain is having same degree of unsaturation and same number of carbon atoms, then you need to consider ring as your parent chain and alkyl side chain as a substituent. Okay. Sure. Let's see the examples of it. See the examples of it. The very first. Now here we did counting from here. 1, 2, 3, 4, 5, 6. So at the first you got what? Ethyl substituent. Okay. Then what did you write its name as? 1-ethyl cyclohex 1-ene. Right? 1. Now obviously this part is smaller. Anyways, वो पार्ट तो वैसे भी छोटा था रिंग से, तो वैसे भी वो सब्स्टिट्यूट ही बनने वाला था. ऊपर से your ring has a double bond, that means it has unsaturation, right? Similarly here, 1, 2, 3, 4, 5, 6. So this is 6-ethyl 3,3 dimethyl cyclohex 1-ene. Okay. Chalo, moving ahead. So this is the part which I am going to tell you, that if more than, okay, let me tell you this part. Suppose, look at this part now. Suppose unsaturation is present outside the ring, as I told you. If the alkyl side chain has an unsaturation, then no matter how many carbon atoms are there, you need to consider it as a parent chain. So here, what is the name of this compound? This is methylene, CH2 double bond. Okay, this is what? CH2 double bond. So what do you name this? Methylene cyclohexane. Similarly here, see they are having same number of carbon atoms, 3, 3. But alkyl side chain has what? Double bond or unsaturation. So you are considering this as a parent chain and this as what? Substituent, right? So that is why you name this as 3-cyclopropyl. This is your substituent. 1, 2, 3. 3-cyclopropyl, prop 1. Okay. Similarly here also, both of them are having same as we see the first possibility. When both of they are having same number of carbon atoms. So here there are 6 carbon atoms in the ring, 6 carbon atoms in the alkyl chain. One double bond in the ring, one double bond in the chain. Then what do? You take cyclohexene ring as a parent chain and this has what? Substituent, right? So this is 1, 2, 3, 4, 5, 6 and here you should start counting from here 1, 2, 3. So to the parent chain it is present attached at the first position and as the Iupac rule you need to name the substituent also according to Iupac. So you would start counting from here 1, 2, 3. So 1 hex 3 in dash cyclohex 1. Okay, that is how you should name this compound. Now the last part of this ring wala compound. If more than one alicyclic ring is attached to single chain, if more than one alicyclic ring is attached to single chain, the compound is named as a derivative of alkene and the ring is treated as a substituent. Whatever we had seen till now, before we could reach here, that was applicable when there was only one ring. What if there are more than one ring? For example, here you order 2 cyclopropyl rings. See, one this is first, this is second, and this is what? CH2. Then what do? CH2 is your parent chain now, and that is methane only, right? And methane is attached with the 2 cyclopropane rings. So what do you write? Dicyclopropyl methane. Similarly here, 1, 2, 3. First position cyclohexyl, third position cyclohexyl. So what do you name this? 1, 3 dicyclohexyl propane. Similarly here, 1, 2, 3. You got a propyl hexyl. Between P and H, which comes first? H comes first, right? So that's why you take cyclohexyl first. And you should start counting in that case from that side only. So that is why here you will start counting from here. 1, 2, 3. 1 cyclohexyl. Then what? Not actually 4, okay? It is third. 1 cyclohexyl, 3 cyclopropyl propane. That is how this is named, okay? So that is what it for naming of all the cyclo. Okay, I hope you must have understood it pretty well. You must have enjoyed it also. If you really do, please like this video, comment on it. If you have any doubt regarding this, subscribe to Practical Live on YouTube. Okay, and please keep on watching, keep on tuned with this so that we can bring more and more such courses. You can also download our app from Google Play Store or Apple Store. Okay, you can log into it. You can explore different courses. For example, Vedic maths, coding, chess, robotics. We have courses in all those subjects. And recently we started a course in a Python also. Okay, but for that you need to log into it. And we have also launched scan anything feature in our app. But for that, obviously, you need to download our app. You need to log into it. Okay, so because then only you can enjoy those things. Okay, chalo, bye bye from my side. Good night.